Hi, this evening we want to take a look at topic modeling for text analytics. All right, so topic modeling is an algorithm that what it's going to give us, it will give us an inference on what are the overall topics of our documents, and it will also give us something that we can use similar to principal components regarding our document term matrix. So the big idea here is what we're going to do is we're going to take our document term matrix. Remember that is a count matrix. Each row corresponds to a document. For us in our project, tweets, each column will correspond to a term that's in our documents. So terms are in our tweets. And then the entries are the number of times that term is used in the tweets. Okay, so what we're going to do, we're going to do something that is similar to principal component analysis. It's not quite that, but we can think of it as being similar that way. And then what we're going to do, we're going to look at which terms contribute the most to each of those components. Here they're topics, and the ones that can contribute the most to those topics are the terms in a topic. Now, something that's very important about this and how this is very, very different from principal component analysis is that in principal component analysis, if I tell it to give me 2 or 3 principal components, the first principal component is going to be the same either way. The second is going to be the same either way, up to a plus or minus sign. If I say, give me 50 principal components, the first and the second are going to stay the same as they were when I was just getting 2. Up to plus or minus sign. That's a neat feature of PCA. When we do topic modeling, because of the method of matrix factorization is different, the number of topics I choose to use is going to give me different topics. In general, the more topics I choose to generate, the more nuanced my topics will be, and the fewer terms that will be in there. All right, so let's go ahead and let's take a look at running this on our tweet data. So remember, I took the major Democrat and President Trump's tweets, and this includes retweets of other people, by the way. And I'm going to make a document term matrix, just like I did in the previous videos. And then we're going to run topic analysis. So the first part of this, I'm just going through and I'm preparing the data to get my document term matrix. All right, so just load it. And Edward in our class requested that these data sets would be posted in the Canvas. These are in Canvas now. Just waiting for you to run this code with it as you want to. Now, I did this over lunch at work the other day, all this code. So I changed how I prepared the data. I did things a little bit faster and quicker. I'm not going through the nuance like I did previously. I'm just trying to do as few steps to get a decent corpus as possible. So, one thing about this is we only want the name and the text. Remember, the name is our target variable when we do our classification model at the end. And so I load the data, and so here I'm using read CSV. What the lapply function does is it grabs all of the tweets or all the file paths of the tweets, and then it runs read.csv. If I want this to run faster, I'll use readR's read_CSV. I just wanted it to get faster. I was just trying to type it out pretty quick, and the data sets aren't big, so I didn't worry about it. And something that's nice about the dplyr package is that it will bind a list of data frames into one data frame for us, quick and easy peasy lemon squeezy. All right, so I use the //W to get rid of all of the non-word characters in our text, and then I got rid of all the numbers. I'm doing this a little bit differently than last time, just because I just feel like doing it differently. You can do it in multiple ways. Stringer is probably the faster way to go. And then I get rid of excess space. So this takes 2 or more spaces and reduces it down to 1. I remove stop words. And I'm pretty aggressive about removing stop words on this. You notice I do it with 3 different stop word dictionaries. So I use the TM package English, and you notice I don't have to write out English on this one. It'll take the full word English or EN. I use SMART, and then I use the top 200 words from the QDAP dictionaries package. And that generates a bunch of white space. So I go ahead and just trim it down. Now, as I worked through this, I found like some other characters that just didn't make sense for what I was doing, so I went ahead and just got rid of them. And as I was going through, remember, I didn't remove any URLs or emails or hashtags or anything like that, so I had some stuff that is not useful. In the previous video, one of the candidates, I think Tulsi, had AMP as one of her major words. AMP is something like technical for Twitter to operate. I don't know what it does, but I looked it up and I'm like, oh, well, it's not useful. So I know I need to get rid of the word AMP. I noticed that, so previously I actually did topic analysis as I was working through, and I noticed that American and America were coming up as separate terms in the topics. And for this purpose, I feel like these should actually be the same. If we were doing something like with geography and social studies, so like if I was doing geography, America would be different from American in sense of like a social studies aspect. So but for this one, I think when people say America, they're referring to the American population. So I want to replace every time I see American with America. And I saw, after doing the replacements, I saw this frequently, so I just replaced it with that. And I replaced the real Donald Trump with Donald Trump. And that is his Twitter handle. And Trump A was all over the place. And now this comes from after replacing the international characters with regular A. So clearly it's supposed to just be a Trump, so I replaced it with Trump. And then the word like presidential is not getting stemmed to be the same as president. So I went ahead and converted them to the same stem. So realize that I am stemming these words already. Is that here in the video? In here, where is it? I know that I did stem the words. All right, I guess. Okay, so I went ahead and stemmed the documents. Notice I did not do stem completion. The reason why I did that because it just takes too long. For our purpose, it doesn't really matter. If I was sharing this with people who are not familiar with text analytics, I would have to go through the process and complete the words. One thing I can do to speed that up, though, is if I get a lot more aggressive about removing words, removing stop words and removing sparse words, that will solve a lot of problems with computation time. But then again, I'm also losing something at the same time. I'm losing those words. Just like everything else in data analytics, it's a Goldilocks problem. You have to find that balance. A lot of times you have to run through, look at what you got, decide if you went too hot or too cold, and make adjustments and start from an earlier step in the process and redo. Now, if I was going to complete the document, I would need to have a dictionary. So this is the step that I use to create it. That what this does is splits all of the words and the tweets into individual into character vectors. So for each tweet, there's a character vector of its words in the order in which they appear. And then what this does, this makes all of those individual character vectors, the unlist function puts them into one long vector. And so by doing it this way, the frequency of a particular word is present in there, and the stem completion function can figure out which one to use for completion if I want prevalent to be the one to use. All right, now I take our prepared text and I create a corpus. So remember, I have to take the character vector, I have to put it into vector source, and then I have to create the corpus with that. And then now I have a corpus, and this is a faster, easier or not maybe easier, but another format to store documents in. Some functions perform better, faster in this format, especially in the TM package. Now, once I have the corpus, I want to create my document term matrix. So I just take the corpus, put it in the document term matrix. On this step is when I get a matrix where the counts tell me how many times each word appears in each document. And then I go ahead and remove sparse terms. So if the sparsity is 95%, I want to get rid of it. So if they have 95% or more zeros, the word gets thrown out completely. So if a word only appears once in all documents, it's gone. Alright, so now let's take a look. I use the inspect function on my document term matrix to see what's going on. Alright, so this is how many non-sparse entries I have, and this is how many entries I have total. So the sparsity is just under 90%. Maximum term length is 8. And so here we can see some of the terms. Alright, so now let's go ahead and let's remove rows that have, so as I've gone through and done my data prep, some of the words were just completely removed by this process, either by removing sparse words or by removing stop words. Between the two of those steps, I've lost, some of the words, some of the tweets have lost all their words, and because of that, they're just all zeros. So they're not useful. They're not helpful. So let's go ahead and get rid of all those tweets. Now, when I do this, because down the road I want to do a classification model, I need to make sure that where I'm storing my target variable in tweets, I'm removing the 0 rows from the document term matrix, and I'm removing the 0 rows from the document term matrix also. So I have to do it twice. Now, when I do topic modeling, the most common way to go about this is with a latent Dirichlet allocation model. All right, so the Dirichlet distribution is where we take like a weighted average of gamma distributions with the same beta parameter. And that will be, so it's a weighted average, and sorry, not weighted average, it's a convex combination. This will give us a probability vector. So Dirichlet distribution is a distribution of probability vectors that arise from taking gamma random variables, all with the same beta parameter. They can have different alphas. Then we take all of those and we divide by the sum of all of the gamma random variables. And since we're dividing by, we've got all non-negative values, and we're dividing by the sum of the non-negative values, we get a probability vector. And then that is the Dirichlet distribution. Alright, so now let's go ahead and let's build a Latin Dirichlet allocation model with 5 topics. Now remember, when I do this, if I choose 4 topics, if I choose 6 topics, I'm going to get different topics than what I get when I choose 5, because of the method that is used in the factorization of the document term matrix. So the more topics I have, the more nuanced they're going to be. And now, which way is the best way to go? What's the best number? I'll talk about that towards the end. All right, so now